One of the most important things you might be asked to do on the CLEP is to find roots of degree 2 or quadratic polynomials. There's two important ways to think about doing this. The first is what's called factoring. Okay, and this is in which we write our quadratic function as a product of two degree 1 polynomials. The second is both more complicated if you think one way and simpler if you think another way. And that's what's called the quadratic formula. Okay, so I'll call this 2 here. What it tells you is that given any second degree polynomial, right, the coefficients could be anything, A, B, and C. I can tell you exactly where it's equal to 0 just by plugging into this formula here, QF, quadratic formula. So why do I think it's more complicated than factoring? Well, it requires you to remember this formula. Okay, negative b plus or minus square root of b squared minus 4ac over 2a. But you just saw me say it, right? That's why I say it's simpler. Because once you remember this formula and you can keep it saved in your memory, then solving these problems is a piece of cake. Because all you have to do is plug in every time. So you sort of pay an upfront cost of remembering this formula, and then you get to use it forever. It's also somehow better because factoring only works sometimes. Quadratic formula works every time. I'm a quadratic formula guy, but other people prefer factoring. I'm going to show you examples with both. So let's look at one. So here I have a degree 2 polynomial that I would like to write as a product of linear polynomials, of degree 1 polynomials. So let me show you how I would do this. I'm going to put x here and here, and this makes sense because I want to end up with x squared at the end. X times x will give me the x squared. Now, the choosing what to add here, what goes in these spots, is a bit harder. Well, what do I need to put here? I need to have numbers so that when I multiply them, I get 8. And when I add them, I get 6. Can you think of anything?
Yeah, continue, no problem. Go ahead.
Well, how about 4 and 2? Does this work? Note that 4 times 2 is 8, so that works. And 4 plus 2 is 6. So this is exactly what I need. So stop and think about that for a moment if you're not familiar with this concept. It's very important. Something you can always do to make sure you factored correctly is to undo it, is to check your work by expanding what you just factored. So let's look at how that works here. So I have x plus 4 times x plus 2. I'll multiply this out using my order of operations. So I'll have x times x, this goes here and here, plus x times 2. And then 4 gets multiplied here and also here. So plus 4 times x plus 4 times 2. And I want to check that I ended up with what I started with. And I do. Very nice. Okay. So I highly recommend, until you become very comfortable with factoring, to check your work. Okay, it's very easy to sort of get mixed up with these. Okay, but if you check it, it will become clear if you made a mistake or not. If you're asked to factor something on the CLEP, it will be doable, and keep in mind it's a multiple choice question. If you really forget how to factor, or it's just not your day, something you can do is try every multiple choice and expand it out in the way I just did and see which one gives you the correct answer. It's not ideal, but it might get you a couple extra points you wouldn't get otherwise. So something to keep in mind. All right, so let's look at another example. Here I have a negative sign on the second linear piece, right? I have minus 6. So again, we ask the same question. I want to write it as a product of two linear terms. I'm going to put x's here because I need an x squared at the end. So I ask, are there two numbers so that when I add them, I get negative 6, and when I multiply them, I get 9? So just think about that for a moment. Well, let's try some things. How about plus 3 plus 3? Well, 3 plus 3 is 6. 3 times 3 is 9. So I'm wrong here. I wanted negative 6, but I'm right here. So this would give me, if I were to expand it out, x squared plus 6x plus 9. I want minus 6x. Well, thankfully, I can change this rather easily. This is wrong, but x minus 3 times x minus 3 works. Okay, so minus 3 plus minus 3 is minus 6. Good. And minus 3 times minus 3 is still positive 9, right? Because the negative signs cancel when I multiply. So this gives me exactly what I need. Again, we'll quickly check this one. We won't go as slowly as we did before. So x squared minus 3x plus 9. So I get what I need. Good. Again, I think it's helpful to check your work for these things. So let's look at an example where I think factoring might be too difficult. I think you could play this game all day and try to figure out, okay, what two numbers add to give me 7 and multiply to give me 9. And I think you'd have a hard time doing that, okay, because this is not an example where factoring is ideal. And in fact, we don't ask you to do that. So if we look at this example, I don't say factor it. I say find the roots of it. So this is begging out for the quadratic formula. So what does that tell me? It tells me that x squared plus 7x plus 9 equals 0, right? This is what it means to find the roots. If and only if what? X is equal to negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 9 divided by 2 times 1. So here I'm just plugging into the quadratic formula. A is 1, B is 7, C is 9. And I'll simplify this, so negative 7 plus or minus, okay, in our heads, 7 squared is 49. 4 times 1 times 9 is 36. So now I get negative 7 plus or minus square root of 13 over 2. So those are my roots. Okay, and notice that there are two of them. One for the plus, one for the minus. Because this is typically the case with second degree polynomials. Almost all the time, they will have two roots. There are special cases where you only have one, but those should be considered exceptional and not the rule. We will look at those as well. Okay, so just as a final exercise, let's look again at at a factoring exercise. So let's look at x squared minus 4. Well, this is kind of different, right? There's no x term at all. It's just the order 2 term, x squared, and the constant term, 4. So can I play the same game? Well, in fact, yes. I'll start the same way. So what do I want to be able to do to factor this? I want two numbers so that when I add them, I get 0, and when I multiply them, I get negative 4. 2 minus 2, right? So 2 plus minus 2 is 0, and 2 times minus 2 is minus 4. Okay, so I claim this will work. And again, we always want to be thorough and check our work for these. So let's expand x plus 2, x minus 2. So I have x squared minus 2x, I'm sorry, let's say plus 2x plus 2x minus 4. And the key point is that these terms cancel. So I get x squared minus 4 as desired. Okay? So in this case, even though there's no coefficient on x, right, this is of the form ax squared plus bx plus c, where b is equal to 0. So even in this special case, you can still factor. And of course, we could have also used the quadratic formula to find roots of this polynomial.